In this video, we're going to look at all 6 trigonometric functions of any angle, kind of add on to what we did at the end of the previous class when we had an angle in the coordinate plane and drew a triangle to figure out all sides, and then we could find all 6 trig functions. Probably do a couple of these, and then basically that's it in this video. Excuse me. So in these problems, essentially what's happening is we're given 2 conditions. We're given here that cosine of theta is equal to -1/3, but we're also given cotangent of theta is greater than 0. Another way of thinking of this being greater than 0 is that cotangent is going to be positive. Okay. Now, we don't have the unit circle, but I'm going to draw the coordinate plane on here. If you have your unit circle, that might be a good thing to get out. So we have x comma y. We know x is cosine, sine is y. And the reason I'm doing this is so I can refer to it. We didn't do this in class, but I think it's good to refer to it in the video. In this quadrant, everything is going to be positive. The x is positive, the y is positive. In this quadrant, the x is going to be negative, but the y is going to be positive. In this quadrant, the x is negative and the y is negative. And in our fourth quadrant, the x is positive, but the y is negative. Okay. So that might be a good thing to put on your unit circle, honestly, but up to you. I'm going to refer to this. We did this in class using the unit circle, but I don't have that handy. If you have yours, it'd be great to take out. But in this first part, we want to figure out if we can determine which quadrant theta will align, and if so, explain our reasoning. So I'm going to again draw quadrants. Now the idea is that we have 2 conditions. We have cosine of theta equals -1/3, and cotangent of theta is greater than 0, or that it's positive. What's going to happen in these problems is we're going to use this first condition to eliminate 2 of our quadrants, because we want to figure out which quadrant theta is in. That's the goal in this first section. And then once we use this piece to eliminate 2 of our quadrants, then the cotangent being positive, that'll also eliminate another piece, another quadrant. So if we look here, cosine has to be -1/3, or it's negative. But if I look at my quadrants, cosine, that's my x value. So cosine's going to be positive. Cosine's going to be positive here and here in these 2 quadrants. Cosine's going to be negative here and here, which is what we want. So because cosine is negative, we know that theta cannot be in this quadrant or this quadrant. So I'm going to put an x here and an x there. Again, cosine is the x value, and so the x value would have to be negative in order for our angle to be in that quadrant. So we can eliminate quadrant 1 and 4. Now, we want to know which quadrant of these 2 using cotangent being positive. Excuse me. Well, if you'll remember, we said that cotangent is cosine divided by sine. And so if we're looking at these 2 quadrants, if I look in this quadrant, cosine is always going to be negative and sine is always going to be positive. So if I have a negative value divided by a positive value, that will be negative. So it's probably not going to be in this quadrant because we would need cotangent to be positive. Similarly, if I do cotangent anything in this quadrant, a negative divided by a negative gives us a positive, which is what we want. So that means that due to cotangent being positive here, the quadrant we're looking at is this one. To kind of go back over that, what this is saying is that in this quadrant, in quadrant 3, that is the only place where cosine will be negative and cotangent will be positive. So we know that theta is going to be somewhere in this quadrant. Now, I'm going to redraw coordinate plane. We know that we're going to be in our third quadrant. Now it's saying to use a sketch. So the idea is that we're going to use a triangle. I'm just going to draw a line. The line doesn't have to be to scale. It just needs to make sure that we're going in the third quadrant because that's where our theta is. And what we can do here is similar to what we did last class. We can draw a triangle in this quadrant. The dotted line creating the triangle always goes straight to the x-axis. We have a 90-degree angle there, and then our reference angle is always going to be the one closest to the origin. We're still dealing with this. The cosine is negative 1/3 and cotangent is greater than 0. And the idea is that we can use something here in our original problem to actually label some sides in this triangle. And what we talked about in class is cosine being negative 1/3. Well, that is the same thing as adjacent over hypotenuse. And actually, I'm going to rewrite the negative here in front because that's where it was there. And you'll kind of see, oh, sorry. And you'll see why that's the case in a second. So what students said is if this is adjacent over hypotenuse, this is the angle we're looking at, then the adjacent would be here. That means that would be 1 because that's the adjacent, and the hypotenuse would be 3. And that's true. Excuse me. The only problem is we had this negative in front. I put the negative in front for a very specific reason. And that reason being the negative has to go on the 1 or the 3. We need to be careful, though, on where we sign the negative here. And what we talked about in class is if we start at the origin, if I'm moving to the left 1 unit, that means this will be negative 1. Another thing that we know is the hypotenuse is a distance. And so because that is a distance, the 3 will never be negative. It will always be, the hypotenuse will always be positive. Okay, so what we have so far, recap. So we figured out that the theta is going to be in the third quadrant. We also know that we can draw a triangle and label these sides according to what cosine is. Now we can solve for this third side using Pythagorean's theorem. So I'm going to write Pythagorean's theorem over here. The only thing is using Pythagorean's theorem here is we need to be careful because we're given C. C is the hypotenuse. So a little different than what we did last time because we're not given the B value instead of the C value. And I'm going to solve this quickly. I would recommend you doing this on your own. And I wanted to pause here because anytime you have something squared, you need to pause and rewind, that's fine. Something squared and we take the square root of both sides, the square root of 8 does not come as a whole number. So I'm going to leave it as a square root of 8 for right now. But anytime we take the square root of both sides of an equation, you will always have positive and negative square root of 8. Now that's specifically important here because now that gives us an option. What that's telling us here is this is our B. Either this dotted line is going to be positive square root of 8 or it'll be negative square root of 8. And after talking about it in class, we said, well, if I'm going here to the left, that's negative 1. And if I'm going down, well, that should be negative as well. So because we're going down from the x-axis, this would be negative square root of 8. If the triangle was in the second quadrant, then that would make it positive square root of 8. Now we can solve for sine, cosine, and tangent. We have our angle, we have our reference angle here, and we have all three sides. Now we can get our 6 trig functions. Sine being opposite over hypotenuse, so that would just be negative square root of 8 over 3. Cosine would be adjacent over hypotenuse. We're also already given cosine, so that should be verified that that's negative 1 over 3. Tangent, opposite over adjacent. But if we simplified that, that would just end up being the square root of 8, because a negative divided by a negative gives us a positive. Now we can do the other three. Sine is related to the cosecant function by taking the reciprocal. If you rationalize, I'll let you do that just for time. That would be -3 square root of 8 over 8. Cosine is related to secant. The reciprocal of -1/3 would be -3. Cotangent and tangent.
Did you like your ringtone?
So that means that if we were to rationalize here, you would have square root of 8 over 8. So those would be your 6 trig functions based off of the conditions here, getting all three sides, and actually solving for 6 trig functions. In the next video, we'll do one more example, and then I'll explain the review.